Great, let's start. Kind of intimate session here up in this small lab. So, half time. After this, we have half of the lecture. And so we're coming now to, it's actually not project 2, but project 1. And in good style, I will tell you a story about that. So, a couple of years ago, when I started with kind of doing bigger things in Internet of Things, I was approached by a friend who was building a sailboat. And he said there's a business opportunity in actually putting Internet of Things on a sailboat. Said one of the major challenges on a sailboat is to monitor all the different liquids on the sailboat. He would like, when he's actually, this is actually the real boat we were talking about. So he wants to monitor actually the fuel, the wastewater, so dirty water with lots of stuff in there, the fresh water, and the water in the air conditioning system and the heating system. So, and he was wondering, so which sensors, what can we actually use to implement that? How? Where do we have this to mount the sensors? How can we have a nice dashboard? How can we connect it so that if the boat is kind of rented out by somebody else, that I still get some warnings if things go wrong? So, as we have a lot of sensors we can use for measuring liquids, your task is actually to develop a solution for my friend how we can equip a boat and report on all these liquids. So we have here weight scales. We have different types of distance sensors, lasers, acoustic, or you can even use with an LED which can actually receive intensity of light, and you can kind of do a calibration and depending on the liquid still figure that out. We have a rainwater sensor, so basically conductive sensor, and you can see how much water is there, and depending on the water it will give you different results. And we have tons of different switches where you can kind of look at different levels of the liquids. However, so this should also work when the boat is out on sea, and so there might be waves. Yeah, so you still have to always kind of keep in mind that we also have to do some averaging or, yeah, kind of deal with the waves. Do we need to install multiple sensors? Is it enough to install one? So how can we deal with that? So I call it the measuring liquid challenge with the different sensors. However, so this will be next week. It's just to get your minds up for it, what it is, but you need some props. So I need you to bring some stuff to be physically active. And so I need you to bring some kind of old plastic bottles of water where we can put liquids in and kind of experiment with. So at least one bottle where we can put clear water in, one for vegetable oil, and yeah, and you have to find some dirty water you can experiment with. So also, I would like you to find some cheap vegetable oil, kind of, you can, no, maybe not with, we don't want to have diesel here in the class, but so you want to probably have something which has similar properties in terms of weight. So try to organize a couple of bottles of vegetable oil, yeah? This is really cheap. You don't have to bring good oil. You also want kind of to bring some kind of cardstock or cardboard material because you might have to block out light. Some of the sensors are not really good with daylight and they kind of get confused, and also the tanks on a boat usually don't have, they're not out of glass, they're out of metal. So you want to actually have something which blocks the lights to have the real situation here. And anyway, you want to have a little bit of paper cardboard to do some setups, like a swimming thing. Maybe bring a couple of wine corks. I think that also might help in the thing you're actually building. What would really help is, and I've never found a nice way to order them, magnets. Yeah? So if you have some magnets at home, please bring some magnets, because we have a lot of sensors which can actually measure a magnet. The Hall sensor and some kind of, the others just kind of two clips which kind of go together when you bring the magnet near. So some kind of swimmer, and then we need scissors and glue. Yeah, so we need to be really crafty in the team. So you should kind of try that you have each of these things to be creative and to build the real props for our measuring challenge. And then you will actually start measuring and calibrate and try to make predictions of if this would maybe work on a boat. So, and then you will actually start doing real experiments. You will check out with each of the sensors you have chosen how well that performs for the different liquids in the task. So make a big table, document your process while you are doing that. So because in the end, and then of course you want to build a little dashboard kind of monitoring this, so fake it a little bit that you have the different tanks and that they can show it at the same time to you, so you can actually build up kind of the mini boat setup right in front of you. So, and then I want you to be critical again. So I want you to make a recommendation. So you should actually say best thing for your boat would be if you use these sensors, and also tell me why. So why should I not use the laser sensor? Or why can't I use the acoustic sensor for something? Or why might using scales be not the best thing on a boat? Or, yeah, so, but it could be also a good thing. So don't take my word now for it. I want you to make this decision. So, and then, yeah, I want you to make a very brief installation manual and point at the products you want to use. And case. So as it's a little bit of a solution, and of course you like the idea of my friend, you want to have, again, you want to take this big. You say, there's a big need of other people who want to have this on their boat? There seems to really be. So this is actually something you might be able to sell, maybe not in Austria, because there are lots of boats on the lakes here. So, but maybe more in kind of coast towns where there are bigger places for yachts and sailboat. And so you want to make kind of a little business pitch in the end of this, where you kind of show your system in action. So you pretend that you are on the boat, and how would kind of a little case in there play out? How would you use your system? How would it look like? You can, so most of this you should document. You don't have to make a movie at that point. I want to see a little playthrough of your scenario, and then when this project is done, of what is going on there. The final project, you will do the same thing, but you will make a real movie out of it. At this point, I just want the documentation of all this kind of comparison experiments you make, kind of some pictures of the setup, and kind of screenshots of the dashboard you built, and a story which gives me an idea how you would present this in the end. Okay, so that happens next week. I think mainly we'll commit next week in building that. There might be some small things that you learn, new devices, but this will be ongoing the whole time in this class anyway. So this, plus I will teach you kind of how to use some of the things you haven't tried out yet. So, but of course you will learn with the challenge, you will learn how to use the scale and how all the distance sensors, how you kind of deal with the analog sensors, how you can make filters, how you can do a median. So that will be basically part of learning with this challenge, or for enabling this challenge. So that is project 1. This is 10% of your total grade. And usually it's a lot of fun, a bit messy in class, but I have gotten good feedback for this exercise usually. So don't worry, not too much here. So because I will present to you, today I will basically show you a little bit of the Flogo stuff I've done. I forgot my power supply yesterday in the university, so I didn't do as much last night as I wanted to do. This is also why the movie is not yet online. I do apologize for that, but so the movies will come this weekend, and I will probably start in the lecture have 1 or 2 more little Flogo presentations. So, and then you can make up your mind if you prefer Flogo to Node-RED, or if you want to do something completely different. So, but today after Flogo, I will show you part of my own framework, which I developed for teaching, which I hope you enjoy using. It's a combination of something I built with some of the previous students and Node-RED, and a lot of stuff running on the Raspberry Pi, as you have seen. And I will try now to dig in and kind of give you a little bit of a head start that you understand what is actually going on there and what you can do with it. However, so I want to kind of make something like a little game. I want you now to think what you would like to have in such a system. And then you want to, while I present it, check off some of these ideas you have. And I hope, of course, you will check everything off, but maybe you also have some new ideas I can implement at a later point, or you could outline and help me in terms of getting to this implementation. So 5 minutes, you want to think about what you want to have in a framework that supports you building an Internet of Things system. Just a list of features. Just, when you can look at here, there's some examples, so usability, documentation, and such stuff. You can all write that down, yeah? So I want you to make a list of 5 to 10 points now in 5 minutes, what you would like to have in an Internet of Things supporting framework, or an Internet of Things supporting platform. You could say, oh, it needs to run in the cloud or be hybrid. It needs to be a hybrid integration platform. So these should be easy to integrate stuff. And this is not lecture notes. This is the research report. We can actually make it that you check it off for two things. You check it off for Flogo and my framework. Yeah? So then make, in the end, what of these things does Flogo offer? What of these things does my framework offer? And then we can have, in the end, a discussion. Good. So make some kind of initial thing, like this is my first choice, going to make a line or so, and maybe if you now get more ideas while I present the frameworks, add them later. But I think it would be nice to see a reflection kind of before and after what you have done. So just make a mark, kind of what you've collected until this point. And then later we can see, yeah, you checked out the boxes, or no, I had completely new ideas. And even if some of the features you presented were okay. So we skip that one. Why is this here? I wanted to do Flogo first. Oh, okay, I forget the Flogo slide. So, okay, why don't we stay here? So, I've showed you kind of the links, and a lot of you have already played with the Docker container, with the WebUI and Flogo. So I will just give you a very, very brief thing of what you can do in kind of combining MQTT. But this will still leave a couple of open questions. So I have to first check if my Docker container is still running. So sudo docker. Yeah, this is what I was thinking. I actually don't even know how no, this basically means it's still running, so I should be able to just go to the Flogo site. Yes. So there's some weird things which I don't completely understand in Flogo, which is kind of when am I allowed to log. So you might have looked at the sample app it comes with, and in the sample app it has this logger thing here. Yeah? So if I do the sample app, it actually is able to send me a log message. So it actually prints out the hello world I have back here. This somehow does not work if I use MQTT as an input. So it has something to do with the trigger, and the trigger being able to convey log messages back out. So if you find the solution here, please let me know. What we could try which I haven't tried, is why we could probably have the same trigger, because you can have several triggers here. You could actually try, if we add 2 triggers, if one of the triggers can return the log messages. So, but I think most of you have come to this point that you can connect to the Docker container, yeah? So if not, ask me in the lab today. I will try to get you to this point. It's a little tricky in Windows, but I think thanks to some of you who have actually shared all the information, it's possible in most Windows versions also to get a Docker container up and running. So I haven't managed doing it in Linux. So the only thing, if you go to the, I show this later when I'm setting up the gateway. So you can do the command line version there. You can do all the command line examples on the Raspberry Pi. So it's possible in Linux, but it's not easily possible on the Raspberry Pi to run the WebUI. This is why we want to use the Docker container. So, but the MQTT test you can run is the following here. And the strange thing is that we have different results here. So what I'm actually did, I created a little mini action, and I have an MQTT input and an MQTT output. But however, for me, it only worked if the broker had this format here. And I think here some of you have had different results there. So it seems like sometimes that it needs the TCP URI format and the port here in the broker setting. So then you have to define a topic, and you have to define an ID, and that should be all you need here. So as you see, I'm subscribing to the test topic on the gateway or on my local server. So let's kind of set this one up. For this, I have to run the access point. So, because then I have the IP number here on my computer. That's the same thing what happens on the Raspberry Pi. And I have to start the MQTT broker. Sorry, didn't work because I'm connected to the Wi-Fi. So let's disconnect my Wi-Fi network so I can run this other one. Disconnect here. Start the access point again. So I tried to be connected on the same interface to the Wi-Fi as I wanted to host my own Wi-Fi network, and that doesn't always work. So now it works. So now we have the MQTT broker on this address available. So let's check. The only other thing I do at the moment is I send that out on another topic. So I add here another MQTT output. And here I have to give the broker in this the same format, but with quotation marks. I give an ID, and I give the test output as a topic. So, and now I just compile that. So we go here and say I want a Linux version. And I also haven't found anything how to start the debugger. I tried to Google a bit more, but so open challenge for you guys. If you figure out how we can actually run the debugger, please share. Oh, oh that worked before. Great. So the only thing I could imagine is, because some of you kind of saw that the standard here for the input seemed to be without this. So let's try the input just as IP address and try again. Now we pray.
I think you must be connected to the internet to because he's loading dependencies then later.
Oh, that could also be. We can do that. I have 2 Wi-Fi adapters. But does the Docker container need to be restarted to figure out what my internet connection is? So you think I should undo what I've just done? So let's do this here. Put that back in. Save. Let's see if we have internet. Yeah, good, we do have internet. And let's try again. That would explain why Kaivena can actually compile things in 2 seconds and we need longer. But okay, let's try if we can start and stop the Docker container. That's the same. Does that stop? Don't know the Docker commands by heart. Okay. Okay, I will restart the Docker service. Oh, that did the trick. So I'll give you one more test. If not, we just do a continued demonstration. Maybe one day I get it right. So it takes longer. Is there any log going on? It's kind of a little bit magic. It is doing something serious in the background. Oh, I downloaded it. Awesome. So that should be in my download folder. So where is it? MQTT Test something. MQTT Test. Oh, it's probably the number 1. But it should be this one, yeah, today. So let's just take this one, put it here somewhere in my temp folder, and Flogo test. Without the 111 behind. So, and then you take a terminal here, and I have to make this executable. MQTT test Linux something. So start that one. Sorry. Something is running. No, we don't need that. We need IoT. So I will listen on everything which is going on the MQTT bus. And so then let's send something to the test service, MQTT send test input. See? Oh, we have run our first Flogo program. So I send input and I got hello back. Amazing, isn't it? So actually, I cannot show you much more, but at least that works. And really thank for the tip that I need internet connection to be able to compile. else that would have been a little weird. And then maybe we should also note down we had to, if you build up the internet connection after you started the Docker container, you might have to restart the Docker container to have the internet connection, at least the Docker service. It seemed like my Docker container was fine, but the Docker service didn't reroute the new network card which I created. So that's Flogo. So what would be really cool would be to figure out how I can kind of now process the data in between. But I still haven't figured out if the code you enter there is Go code, JavaScript code, or anything else. And I was looking a little bit at the stream examples of Flogo. So there are some labs. I don't know if you've seen on the help page. There are some. So if we are on Project Flogo, go to the documentation. Here are the labs. And I think that's the most documentation you actually get, is playing by example through the labs. But still, they use basically existing components. So I was wondering if you might have to even program your own action if you want to do a transformation of the data you have. Because they do describe in development how, no. I think they do describe somewhere in the labs how you build your own action. Here, how you build activities. So I was wondering if you have to build activities, but I don't know. So I try on the weekend to figure out some more and present this here in class. And if you figure out something today with playing, please share it on Moodle. And then we can kind of take it as a side project and see if we can replace our work in Node-RED partly with Flogo. So let's stop the Docker here and go back to something else. Yeah. So finally, we come to something important. What has coffee to do with Internet of Things? No, so that you understand why I built this system I will present to you now, you need to know a little bit of the history. And because there's some requirements I put in there you might not have picked. So in the first time I dealt with, my PhD thesis was already on home automation. So you could say I'm doing Internet of Things my whole academic life. But the first time I dealt with cool microcontrollers was in Singapore. And that was basically at the same time I started working here. And in Singapore, so my wife was actually working in Indonesia. And I wasn't allowed to work in Indonesia because they have very restrictive policies. But so if I wanted to do some professional work, I always had to fly to Singapore. And Singapore had a great makerspace. And so this guy you see down there is a former teacher who is now the head of the makerspace there. And he started developing hardware for his teaching. So it's not like us plugging things together, but really building a board and designing something. And so when I met him the first time, and he liked coffee because everybody down there likes good coffee. And when he first met, he told me, hey, Uli, look at this device. And he showed me one of the ESP8266 chips and said, Uli, this device will change the world and change our teaching and change how we build things. And I said, are you full of it? Yeah, so why? I don't believe you. And so he kind of started talking about how it's so cool, how it's so cheap, how everybody can afford actually buying these devices and how much power is actually on the device. So already then, that was a short time after Amazon bought 1 billion chips of the ESP8266 to build their Amazon dashboard. And what you see down there is the espresso and the espresso light. Yeah, so up there is a really good espresso of a little cafe in Jakarta. So he was also coming over from Singapore to Jakarta, and so we met there. And down there is the espresso light, and you see our favorite ESP chip on there. So the espresso light is a board William actually designed for teaching. So he wanted to teach disadvantaged groups of kids and grown-ups. So because a lot of people who are very poor or live in communities, they don't have power all the time. but would need or had good ideas in terms of technological realizations. So he wanted to help these communities and kind of teach classes which really enable people. And he kind of got me a little bit on board. So I like the idea that everybody, even not very rich people, could afford hardware and build some things which can better their community and their neighborhood, and maybe then scale. So he kind of says it's a little bit what we are seeing now with the kind of influence of making is the democratization of hardware development. So William who has actually written some interesting books about this topic and how the technological development kind of influences our communities. So this is why this idea of having hardware that is relatively cheap is pretty important for my development. So I wanted to have something where the software doesn't cost anything, where everybody could teach it, not only myself, which is open enough that the community can tinker with it, and which supports, of course, the ESP8266 and something else relatively cheap. What happened at the same time was that I started teaching home automation at the lovely university here in Hagenberg, and it happened something weird. So I didn't have the ESPs when I started teaching here, but I had the Raspberry Pi. And so I was teaching students like you, and there was this weird thing. So nowadays you all kind of know a little bit of Linux. You're not kind of really against Linux, but this time was still kind of, oh, Linux, no, we never use Linux because Windows and Mac OS are the only things which have any importance in the world. However, when I gave the Raspberry Pi and made people work with hardware, suddenly the Linux, Windows, Mac fight became really secondary. So they just really enjoyed playing with hardware and kind of making something physical happen in the world. I know some of you are more software guys and really hate what we're doing here in class and think that's kind of, there are a lot of problems coming with using hardware. But I saw a lot of students who were really excited and got motivation and suddenly did things in Linux even if they didn't like Linux. And they did because it was something on a path, on a purpose. So and it was really striking for me to realize the motivation, what the combination of software and hardware, what the access to the physical world can bring to students. So I was wondering, how can I put this in your education? How can I harvest this motivation? How can I have people really being excited about learning? And for me, I realized that hardware and access to the physical world, kind of bridging the pure software world and the physical world, is a key to doing that. So also my system is designed so that you can have the effect in the physical world very, very quickly. So the idea is that I can show people very quickly that with a very tiny bit of programming, they can affect real change in the physical world. Yeah, and then there's lots of stuff happening in terms of hardware. So the Raspberry Pi is one of the, maybe nowadays one of the most popular computers in Europe. It's one of the major tech industries in the United Kingdom. So basically, if you talk about computers in the United Kingdom, it's all Raspberry Pis. So they've produced 25 million Raspberry Pis until now. And I think it will not go away. The community is so big, so if you tinker, you will usually go to the Raspberry Pi first and then think about the ESP8266. However, I think that's a close second here. And so the Raspberry Pi is kind of around 35 euros. The cool thing is that these boards are kind of around 1 or 2 euros each. And so there's the trend. And so the interesting thing was that this device was the first device that I ever saw students buying after I taught them. So usually the Raspberry Pi is kind of already a little bit expensive. A couple of students would do it, but I always, when I teach with something with the ESP, anywhere on the world, even in kind of poorer countries, people say, oh, I can get 1 or 2 of these to work with. So I think we have reached this threshold. I think, and it might be the coffee threshold to bring the to bring the thread back. Because this thing is about the price in the developed world like a coffee. And maybe that's the saying every student can afford. So I think we have a point where not the university needs to provide all the hardware anymore, where actually the students, not only in university but also in industry or in kind of disadvantaged group, can go out and rebuy some of the hardware they see in class. And I think that opens a lot of opportunities. Yeah, that's what I said. So finally, so this was something which was actually flowing into there. There are, as you have seen already, there are a lot of IoT frameworks. They come with, all of them come with a lot of frustration when you work with them. And some of them allow you to kind of fix the frustration you initially have. When some of them have a community, some of them you can work with it. But none of them has really been purely designed for the teaching purpose. So that's why I set out to design something which can be used in teaching, which is more for teachers and for small classes. Not that I don't think that IoTEmpower can be used even in industry. Some things might be polished, but I think it is at a point where it has some features other industrial products lack. So then, of course, out of the reasons I presented before, affordability was a big thing for me, so it needed to be open source. I cannot make a business yet with the, or I don't want to make a business out of the actual software, but maybe with the services around the software, somebody can make a business. So that should actually be a declared purpose, is if somebody starts working with my software and has a product idea, they should be able, without paying any fees to me, being able to design their own product based on it. Another aspect of this openness is that we can really change the system, we can fix errors, we can analyze the system and dissect it. So in teaching, it's important that I can show you parts, and to show you all the parts of the system you are interested in, and if we don't like something, we can redesign it, leading to extensibility. Somehow it should deal with the ESP8266, but I want to be able to also use different hardware platforms in there. So that's why the core is now based on platformio, so in principle I can use other microcontrollers than the ESP. So at the moment I support the ESP8266 and the ESP32 for the microcontrollers. And there's one point you probably wouldn't have thought, or you have experienced now yourself. Serial flashing in the class never works. I don't know why. So I've taught so many Arduino classes where it's just about Arduino, and then you have to connect the Arduinos or the ESPs to your computer. And I spent 70% of my class fixing cable problems. And it has something to do with computers not having enough power, the cables being broken. So I really hate flashing things serially, because that stole so much of my time. It's frustrating for the students. And so I wanted to build a system which needs very little flashing. And actually, that is something I created in the dialogue with William. So also William's board doesn't have a serial connector. So if you want to flash it serially, you have to use a programmer and then connect the programmer to the device, and then you can flash it serially. So, but if you put my system on there, then after that we can work over the air, and I will show you that. Now, with or without means the next point. Or so you cannot imagine it, but there's still lots of regions in this world where there is no internet. And especially if you want to target disadvantaged groups all over the world, and also in the developing world, I needed something that can work without the internet. So I have to be able to pack all the documentation, all the development environment onto one thing, and then this whole stuff should work without the internet. I think very, very few frameworks offer that last feature. So and then I came up with an architecture after a while, and of course I'm working agile, so this is kind of just a later iteration. So the framework I will present you will kind of look like this. You have a gateway where all the stuff is on, there's running a console on, and you have some web interface of this to interact with this. You can both program the nodes or fog devices from there, and you can program integration on there, so the edge. Then all the devices usually are connected wirelessly to it, but you can also do some flashing for preparation in there. Yeah, good. You can go here to my GitHub page if you want to see more, if you want to see documentation, if you want to install it on a different platform, if you want to report issues. So I'm welcoming you now, starting from that point, to point out missing documentation, features you want to see, things that are not working, and check the existing issues to check that out. So I will show you how that thing works, how it is to set up. Some of the things you have already done, and I gave some special hints in between, but now we finally kind of get an approach to it. And I'll show you a little bit what you can do. And yeah, in the end of the lab today, you can start using it. While I'm presenting, yeah, I want you to make check marks next to the features you wrote before. I hope I can check some of the boxes you have actually put out in terms of features. I know I have maybe you didn't want the teaching focus and that it is really cheap. So that's something which is important for me, but maybe there's some other features you actually like or wanted to have. So check the covered features. Then I want some questions. Yeah, be critical of what I show you. Maybe you have some ideas what else could be done. So I'm very happy to hear this. You can either discuss this in class at the end or put an issue in the on GitHub and say, hey, it would be cool if that would also work. Or have you thought about that? Or if you have some just random questions, what I haven't covered now, say, hey, can you kind of in one of the next lectures can show a little bit more about that? I'm happy to cater to your requests. So what I want to show is flashing serial, flashing over the air, kind of the device management, how it works, and kind of the integration with Node-RED. And then depending on the time we have, I want to show a couple of devices, how easy it is to connect them to the system. So I will kind of continue with the general stuff, which you probably already know. So the first thing is we flash the image on the card here. We put it into the Raspberry Pi, and we connect the Raspberry Pi to power and to internet. So a little bit important for me was like in Cura that there is an idea of a gateway around it. So I always want to think in a system, not only that we want to connect the. So unlike William always teaches only how to connect an ESP to the internet and has a cloud service that can be used. So I was more thinking, how can I have a gateway which can be independent from the internet? This is why my system is kind of targeted to be on a Raspberry Pi. So that's why you get this setup like this. It's also kind of grown out of actually here the university, because it was really hard to get a Wi-Fi which serves all the ESPs in one classroom, and then we discovered that we can use Wi-Fi on the Raspberry Pi 3. And since the Raspberry Pi 3 is out, yeah, we can actually share a small Wi-Fi for each student. We experimented with little routers for all the students, but we didn't spend enough money for routers, so we bought routers for $20 a piece, and then they failed in class. And so actually, even if some of the Raspberry Pis also fail, they're still more reliable than some of the cheap routers we have dealt with. And so it's kind of a nice choice there. So I hope I can see my internet now. There's my IoT Empire. So please don't connect to this one. This is still the default password here. So if you want to wreak havoc on my lecture now, you can all connect to this IoT Empire network. So please don't. Good. So now we should also be able to Google. So if you Google for IoTEmpower, it seems now to be listed first. Why IoTEmpower? It's a little bit a play on words on IoT Empire, because I'm running a community website, the IoT Empire. And IoT Empire is kind of an invention. Hey, what's going on here? The website is broken. Oh, okay, not. So it's kind of a, yeah, like a little bit of running gag I have with a couple of other IoT experts. And actually, so IoT Empire is not my brainchild. It was actually a colleague from Munich who, yeah, does a lot of open source teaching. And so a little bit behind the IoT Empire is we take over the IoT from the open source side, and so kind of achieve world dominion with this kind of free empire everybody can join. So it's a kind of a community web page for especially community projects in the IoT area. And so this is why IoTEmpower is the software which should empower people in this IoT empire. So most of the documentation on the web page is kind of, yeah, let's say it's kind of 90% accurate. So most of the documentation you can actually use to get started. Please feel free to file issues if you find something which is not true anymore. But the English stuff is kind of okay. The Portuguese version is a little bit out of whack. So usually people start here with the Raspberry Pi Quick Start. You have already done that. And what I will kind of show you today is a little bit what is written here in this first IoT node. So we have the Raspberry Pi set up. So you know already we can actually connect via SSH to the Raspberry Pi with using the IoT user. The default IP is always 12.1 in the end. On non-Windows computers, you can just use IoT Gateway here instead. If somebody has an idea how I can convince Windows to accept that, so what I have to provide on the gateway to get Windows to do the name resolution right, make a feature request with solution request, and I'm happy to implement that. So what's on this? I don't know if you know, best tool for the command line ever, no, it's my personal opinion, is the Midnight Commander. So you will see me using the Midnight Commander a lot. It's kind of like a small file manager. It's kind of the first thing I always install when I do some kind of Linux thing. So let's kind of not show the hidden files. So that's basically what's on there. And for you important is there's some kind of, there's the IoT folder, which is basically the whole checkout what is from GitHub. This is IoTEmpower. And there's IoT Test. This is kind of where you put your data and configure your devices. So you will have on yours a node 1. And I did some preparation yesterday with a test node here. But basically, you can make a structure in here, like a house, and say living room, bathroom, garage. And then in there, you can have different nodes, like the garage door, and then the shelf, and this is the same structure you later see in MQTT. Yeah, so basically, when you make subfolders, you get also sub topics in MQTT later. So the fun thing is I wanted to take a little bit this idea of MQTT away so that you don't have to deal with the topics. So I also wanted to reduce configuration issues. So it also, yeah, you have all been setting your Wi-Fi stuff now in there. But this is already where lots of errors can happen, that you kind of put the right parameters in the beginning. So I also wanted to make all this configuration of the credentials and all the security certificates and so on automatic. So let's start with one first node. So there are two ways I can get software on these ESPs here. So one is I flashed, and one is I have I have kind of my basic operating system on here, so it has been flashed before with the software, and then there's a way of adopting this. Because it might have been used from another student with different Wi-Fi credentials, but so I can put this node into something which I call adopt node, with which I then can still send the new credentials over the air to the node. So I first will show you how to flash it. First, kind of the classic way of doing things. And for flashing, you have to connect it to the Raspberry Pi. Very important, once in a while on the Raspberry Pi, execute IoT upgrade. So every time you found a mistake and make me fix a mistake, all of you want to run IoT upgrade on the Pi. Then basically gets from Git the new version, and it compiles all the necessary things, and it builds a new manual, and that's it. There's also an IoT menu. So most of the things you want to do in your daily life, you can even on the command line get in the IoT menu. There's some advanced stuff here too. And this is this. But okay, the first thing you want to actually do is learn how to flash. So we have to be in our IoT test. And here you see in our IoT test, we have this default node. And then is a node config and a setup.cpp and a README in there. So the README you will all probably ignore. My plan was that the README would have some great stories in there describing what this would actually do. And as you see here, as there's also in the top folder is also a README, which should also describe what the whole system is doing. Yeah, so you have the different nodes, and you have a system in which the nodes kind of form together something more. So there's a system.conf. This is usually empty, but the cool thing is you can run my system also on your computer. So you have a Linux computer or the Windows environment, and probably also on Mac, but I haven't tested that yet. You can install IoTEmpower, because it basically needs just a lot of Bash and Python and platformio. And then you can actually set credentials in here. So if you copy this system folder file to your computer, you can also remote deploy from your computer. And as your computer will actually compile things faster, in the end, probably most of you will have some kind of the installation on the Pi, but also a local installation of IoTEmpower, because you can then have faster turnaround cycles in doing that. Especially if you manage the whole folder in Git, you can then even do a distributed access to your system this way. Because most of the things are text files in here, so it's very easy to manage also the whole project in Git. So, but now let's go to a node, and let's see how we can flash that. So we can actually just show it to you nice on the command line, so that's a bit transparent. So I go to the node, and so the default command in here is not accessible yet, sorry. So in the beginning, you have to first once give in IoT. So if you do IoT, you go to the IoT environment. So now we have all the IoT commands available in our service. So I go back here in IoT test and to IoT, to node 1. And I can now adopt this node via the serial connector. So that what I have to say, adopt serial. If you forget this, you can also just use the IoT menu again, and then you can see in the advanced menu there's a point which has initialized serial. This is this adoption step over serial. But okay, I want it to be a bit more transparent, so I will actually do it completely from the command line here. And for this, I have to take any node with a good cable and connect it to the Raspberry Pi. The good cable. And you know that this is an issue. So I connect this, and now what are we flashing? This is the program we are flashing. Anybody understands what we are doing now? What will the flashed device be able to do? Can you read that code? It's C. What do you think will happen after I have flashed my device? What will the device be able to do? You're all programmers. You should be able to read that.
The onboard LED is off and I can connect the button which I can press.
Exactly. So I basically can drive the button and the onboard LED with this. So one is an output and one is an input. Do you have any idea what the topic name might become? So what is the name with MQTT I can use to access these two things, the button and the LED? So it will be under node 1, yeah? So because the whole thing is called node 1 here. So, and in there, the output will be called blue, yeah? So it will be node 1 blue. And the input will be called node 1/b1. Because that is, the first parameter here is the name. So what can I send? On and off. And the button will report depressed and pressed. And the default of the lamp will be off. And actually, this is the on command, this is the off command. You see I'm basically doing the invert here with kind of specifying the values in a different order. So don't want to save that. And let's finally flash adopt via serial. You can give the USB port after it, so you can do adopt serial USB 1, USB 0, USB 1, and so on. So it says something about the dongle. I will kind of tell you in a bit what the dongle is. But first, let's do kind of the things you know. So this is platformio. Some of you have played with platformio and have seen the same output in the terminal from platformio in Visual Studio Code. If you have done the pre-compilation, it will basically get most of the thing from the cache. So we're linking the stuff together, and then you will see, hopefully, that we are flashing the ESP. And it should then directly have the software. It should directly connect to the right Wi-Fi network, the same one which is where the Pi is running on. And we should directly be able to access it via MQTT. But so basically, I will now do the case that it has been flashed by another student. So let's go here on my computer to this IoT temp configs test system. And I have a node 1 on this one too. But this has different Wi-Fi credentials here, my computer. So this is why I have to show you directly the adopt process afterwards. So now I do adopt serial here, which will hopefully work. And then I do the adopt process next. It's an old version. I have to rebuild. Should have made a video yesterday evening. So I did flash on exactly that device. It will say, well, yeah, it works now. But it's probably the current in the air or so, which kind of prevents that. So if you are lucky, you can do that on the Pi. If you can't, it's not an issue. You have to flash one more thing. You have to come to me and ask, or do it on a PC or on the Pi, hopefully. Can you flash us the dongle? So for adopting via the air some other network, you need the dongle. And the dongle you can flash with the command dongle. dongle flash. So if you have a dongle, you can adopt devices into your network without ever connecting the device to your network. To your physically via serial to your network. So see, now we're writing the dongle here. The dongle is a little thing, and you can put a screen on there. You don't have to. So any ESP you can turn into a dongle for IoTEmpower. And it's basically kind of a second Wi-Fi network because they have Wi-Fi on there. So the Pi can continue using their own Wi-Fi network, but it can then use the Wi-Fi network on this one to flash another device, because the other device will go into access point mode, and then this one can connect to it. So we have a dongle now, so you connect the dongle to the Pi. That works out of some reason. No, it works because I do a lot of error correction when communicating with that. And now on the Pi, now we can take this device here. So on this device, so I take this device here, show on the camera. We connect a button, yeah? So you guys have a button, and we have to connect the button from ground to D3. Because this is the flash button, ground to D3. So, and when you have some version of IoTEmpower on this, it will always have a 5-second boot sequence. So I don't know if you see this. This is flashing now, yeah? So during these first 5 seconds, you can put this thing in the so-called adopt mode. So if I reset this here, then it starts blinking again, and it can press the button 2 times, and then it's in adopt mode. So it will now start showing some Morse code on the internal LED. So let's count here. We see one long, 1, 2, 3, 4, 5 short. So it has 1 long, 5 short. Because if you do this in the lab later, everybody of you will have some different things, and you should not adopt the version of your neighbor. So what we'll do now, instead we will just adopt this node. Sorry. We use the menu for that. Because the menu can, in adopt, scan first for the node. So see, we have one node available here, which has blinks 1 long and 5 short blinks. And then we can say, yeah, I want to adopt this one. And now, even if this one is connected to my PC, it can now become part of that network. Sounds complicated, doesn't it? It becomes second nature, don't worry. But this is kind of the first thing. You have to get the original credentials on this device. This is why we're doing that. Come on. Yeah. So you can actually, if you have a screen connected to the dongle, you can see a little bit that it is actually flashing on there. So it's counting up a counter here. So basically the same thing you see here in the command line, you can see on the little screen too. And it's now sending via the air the firmware through that device to it. So what happened in the background, this guy makes up an access point. And when I scan for different devices, I scan for the open access points, then now this dongle connects to the access point and sends the firmware, and the firmware has all the credentials built in. So, successful. So now this guy should be available on net, and we should be able to use the button and the LED in here. And actually you can see if I press the button, then the LED turns on, even if we haven't programmed that. You have any idea who is doing that, the connection between the button and the LED? It's Node-RED. So let's see, there's another way of accessing the gateway. So you can go to 192.168.12.1 in your browser and accept my self-signed certificate, and then you get this web page. There's some documentation, the same documentation you have seen in the net. There's the quick start tutorial here, so you can go there. There's a list of commands. So you remember you had this output stuff. You can see how, yeah, you can actually specify this output command in there. So you can, or if you want to see how the temperature works, you can go here on temperature. There you see the DHT support and the DS18B20 support. That's kind of the way you can support devices. And maybe some of your devices not support, but you see pulse width modulation. You see there's RGB in here, RGB single. And as you see later, you will just need one line to attach the RGB to this here. But OK, this is the documentation, but there's Node-RED. And the password, so username is IoT, password is IoT Empire. Can't type this, IoT Empire. And look at this first flow here. Let's kind of remove that one. Let's see that here. Does it look familiar? See what it does? It maps node B1 to, you can't see that. Let's put this away. To node 1 blue set. See, and this is the connector which kind of makes the button turn on and off the light. So if I remove that connection here, it stops working. So if I now press the button here, nothing happens. If I do the connection again, deploy, I can switch the LED again. Yeah? So let's move the button to a second device, which is the kind of our hello world we did in the beginning. What I want to show you first is, okay, we want to now remove the button here. I show it a different way. So also, if you have opened here the web page on the Pi, you can also, instead of using SSH, edit with something else. So you can go to your example folder here, and password again, as a user IoT and IoT Empire, and see you get a file browser on the Pi. See, there's our node 1, and we can actually also do everything from here. So we can now start an editor, and let's see what this is. So let's remove our input button. We save that, and you can either open a terminal here or get the user menu, and we will just run deploy now. And deploy is a little faster than adopt. And then we get the same thing we got in SSH here, and it asks confirmation. Yes, run deploy. So you have to adopt first, and when you have adopted it, you can always deploy. So it will recompile this, because I now have removed the button from it. There's just the LED on there. No. And then you look at the speed, it sends then the stuff over the net. So it's the second time now, because we have all the credentials on there, and you see now it sends it via the Wi-Fi, and that's kind of the fastest way you can send a new firmware to one of the devices. So now it's the new firmware is on there. Good. So now the button doesn't work at all anymore. Yeah, okay, we will see. It's dead now. So we'll now move the button to another device. Let's take this one. Let's see if I have, I need more USB cables. Okay, we can move that guy to a bad USB cable because it just needs power. Because now we can do everything over the air on that one, even with the bad USB cable. But we need this guy here. I need to adopt it. We take, and I think that's all I will show you today. D3 and ground. D3 and ground. Okay, So that one actually just works out of the box. Let's adopt this guy. So what we do now is we just make a copy of our node folder. You can use also the web GUI for that and make a node 2. And in the node 2, I remove the key because there's a unique key for each of the one, and if you remove it, it will be regenerated. And in the second one, I just switch things around, so I enable the input instead. Exit. Yeah, I want to save that. And I here say IoT menu. And I adopt this guy. And so, yeah, that's correct. Run adopt. While we are adopting this, we change the node red stuff. So we will just say here that we read from node 2. Done. So node red should be adjusted. So after the adopt is done, we hopefully I can show you that I have the remote control done, and so I have basically redone the task from the first lab here. We're compiling. 1 more minute. Please be patient. And then at least I have shown you the hello world. And I will continue on Wednesday to show you kind of more the nitty-grits, which you probably need for getting a scale running, getting all the distance sensors running for making your experiments for the ship. A boat. Well, you can scale up to a ship then. The adoption is usually pretty reliable, so we did that first with a mobile phone, so you had to log in with the mobile phone, then set the credentials manually on the phone. But people hated that, kind of logging with the phone, and then there's so many mistakes you could make then again. So that's why we switched to using another ESP for actually doing the adoption process. Can you kind of, I don't know. I will put this here, and you have to verify that this one is on or off somehow. So let's reboot this guy, and then it should actually work out of the box. I don't know. I show you in the lab. Let's continue in the lab. I think I can show in both labs what was going on.